name is Sophie Parsons, and today I'm going to explain Einstein's theory of special relativity using fruit. Alright, so let's say we have an apple and an orange. An apple and an orange are friends, and they go jogging together. And they move at a constant velocity, the same velocity, to each other. And now let's look at the vantage point of the orange. From the vantage point of the orange, it looks like the apple is moving still, because they're moving at the same velocity. But from our vantage point, that of the camera, it looks like they're both moving at the same velocity towards us. The same goes if we have our apple sitting on the table, and we bring the camera towards the apple. From the point of view of the apple, it looks like the camera is coming towards it. But from our vantage point, the vantage point of the camera, it looks like the entire world, including the apple, is moving towards us. Alright, and now let's say we have a worm in our apple. And he has a headlight and a taillight. And let's say we want to measure the length of our worm using the time difference between the time that the light from the headlight hits us and the time that the light from the taillight hits us. They will both be traveling at the speed of light, but if our apple is moving away from us at a slow velocity, the time between the two will be a little different, and therefore we can measure the length. But now let's say our worm has superpowers, and he can move at very close to the speed of light. Nothing can actually move faster than the speed of light, that's Einstein's whole thing, but you can get really close. And when you get really close, weird things start to happen. So we're moving at the speed of light with our worm, and all of a sudden, the light from the headlight and the light from the tail light are going to hit us at the same time, meaning that the length of the worm is 0. And if the length of the worm is 0, that means that the time for the worm is almost infinite. So it can travel around the universe and then get back to Earth in time to eat its friend, the orange. However, by that point, the orange will be nothing more than a peel, because I got hungry. Whoops. But time for me was a lot more than the time it took for the worm. This can be described by an equation. The length dilation, what we talked about first, that is described by the equation L equals the square root of 1 minus v squared over c squared times L naught. L is the new length, v squared is the velocity squared, c squared is the constant of the speed of light, 3 times 10 to the 8th, and L naught is our new length. The time dilation would be T naught equals the square root of 1 minus v squared over c squared t, where T naught is our old length, T is our new length. Thank you for watching my video.